All right, grade 11s. Here we are starting chapter 8 for this math course. So we're looking now at financial situations that involve exponential functions or exponential growth or decay. Our goals in this last chapter to understand the difference between simple interest and compound interest, and then also to solve problems involving compound interest and annuities. So we'll define some of those things in the next couple of videos. This is a warm-up. I welcome you to pause and try just to get your head in money mode. This isn't part of the actual lesson, just some get thinking stuff. So Netflix costs $14.99 per month before tax. What is the total cost including HST? Can you complete this calculation in just one step? So if you'd like, you can pause the video, give it a try on a rough piece of paper. I am going to move that little box in the corner and show the answer in a second. So if you don't want to see it yet, you can pause. The final answer there is $16.94. And this can be done in one step by multiplying by 1.13. All right, so I'm going to just hide that again. And then get into our actual topic for today. So this involves a little bit of new vocabulary. So here is some of that right at the beginning. Our note's going to talk about using a principal, which is a sum of money that is borrowed or invested. This is like the initial value that we were talking about in our exponential growth notes. Initial value, starting value. So this is either like how much you put in the bank in the hopes that it will start growing interest, or amount of money that you borrow in the form of a loan that you're going to have to pay back interest on. So anyways, the amount at the beginning. Simple interest and compound interest, that was one of the goals, being able to distinguish between those two. So simple interest is earned each year, and then it is deposited into your bank account. Interest is only earned on the original principal. So even though your bank balance is growing every year, to do this interest calculation, the bank will always look back to how much you put in originally and kind of ignore the money that has been added in, the interest that's been growing, which means that the interest amount will be the same every year. So if you put in $1,000 today in a simple interest account at I don't know, maybe 5% interest, every year you'd be making $5 in interest no matter what, even if you left all of those $5 deposits in the account and your balance was growing, you would still be only earning $5 per year. For compound interest, interest earns annually again, but interest earned is reinvested and also earns interest. So this means if you had that my example was wrong, but if you have $1,000 in the bank earning 5% interest, in the first year it's going to earn $50. That's going to get added to your bank account and included in the next year's calculation. So on the next slide, I have a chart that kind of walks through what that looks like. This isn't part of your note that you have to copy down. It's just something to look at so you can understand what that pattern is. Okay, so simple interest, interest earned only on the principal. Compound interest, the interest earned is reinvested and also earns interest. So I'm repeating that just because it's the important takeaway from these slides. And the principal is the initial amount. Alrighty, so on this next slide, there's a chart set up for a simple interest system where your starting balance is $1,000. That's the amount that interest will be calculated on at the end of year one. I'll show you this formula on the next slide, but you've earned $50 interest in the first year, so you're going to finish with $1,050. You start year 2 with that bank balance, but interest is only calculated on the original 1,000. So you're still going to earn $50 in interest, tack that onto your previous bank balance, and that's what you'll start the next year with. So I've stopped showing the calculations just to simplify it a little bit. But with this simple interest, this is always the same. And that means if we're looking at as years are passing, what is our bank balance? We could have even included a year 0 here. We're going up $50 every year. And that has a very hopefully obvious pattern to it if we were to graph it, if we're always adding 50. Okay, so I am going to shift down. You can pause at any point to look at things a little bit closer. But the next chart is a compound interest chart, and you're going to notice that it looks a little bit different. So with compound interest, we still started year 0 with $1,000. That's how much we're going to begin year 1 with. That's going to earn interest, still $50 because the rate was the same. So year 1 is the same for both simple and compound interest. After that, things start to go differently. So with compound interest, our new starting balance is $1,050. That's what the interest calculation is going to be based on. So we actually earn more than $50 interest in year 2. We earn $2.50 extra. So when we add the starting balance and the interest, we can get our ending balance of $1,102.50. So a little bit higher than $1,100. Then we move on to year 3. So we carry forward that ending balance. That's what we're going to start year 3 with. That's what we're going to calculate interest on. And with a 5% interest rate, that works out to $55.12. We add that onto the starting balance for the year, and we're up to $1,157.62, which is again a little bit higher. We're making seven and a half extra dollars in that year. So with compound interest, you'll notice that the interest rate grows, or the interest amount, I should say, grows each year. So that means every year you're going to earn a little bit more interest than you did in the previous year, assuming you leave your money in the bank. Alrighty. So this is now, this went up 50. This one went up 52.50. So it's going up by the interest amount. And what that looks like on a graph, I'm going to move ahead and show you on the next slide. The simple interest pattern was $1,000 adding 50 every time. And that makes a linear graph. And the compound interest one, I've included there the blue dot, so I copied it over from the other simple interest graph, and this was growing a little bit above that. There's a little bit of an increase above the straight line. And if we keep going to year 6, 7, 8, 9, 10, 12, 20, it's going to start growing faster and faster. So this red line it's rough. It is not accurate. But I just wanted to make clear that this is growing faster than linear because it's exponential growth. Exponential. All right, and the exponential part of it is the fact that we're earning 5% every year. So we have a growth rate. So this was a 5% growth rate. That means every year, really, you're multiplying by 1.05 times the previous year. And we're going to do that for how many years? I don't know what number that's going to be. Okay, so there's a formula that would help graph this red line without using the chart. So I could fill in 1 for year 1, 2 for year 2, 3 for the exponent for year 3. and I'd come up with those same values for my chart. Okay, so I put together this equation because we just finished exponential growth, and I know what the pattern looks like. But the next couple of slides are going to go through, actually the rest of the compound interest stuff is going to be in a separate video. Then I'm going to push to tomorrow. We're going to focus today on simple interest. Okay, so this is part of your handout. So you've got a few blanks to fill in that are, again, some definitions or vocabulary. But really, these are the vocabulary pieces that come from our formula. So I'm going to backtrack just to the chart for a second. And show you that that formula was here. I equals PRT. That's the one that was being used. I equals this times this times this. So we're going to define what is P, what is R, what is T, and what is I in that equation. Okay, so I have a finished version of this slide that I'm going to put up and talk about. You can pause to copy out the words. I stands for interest, or amount of interest earned in dollars. So this is a dollar amount of money. It's not the rate. P is the principal invested or borrowed in dollars again. So this is an amount of money. This is an amount of money. R is the annual interest rate expressed as a decimal. So this is exact same as with our exponential growth. We had to change percent to decimal before entering a number in the equation. And then P in that equation is the time in years that the money has been in the bank or collecting debt. So if you've borrowed it, how long you've been hanging on to the money. All right, so there are the variables we're going to be using. If you want to pause and get that down, you're welcome to do that. And I'm going to jump into our 3 examples. Okay, I copied the formula here again, I equals PRT, that we're going to end up using. And I'm going to make a point of identifying which of these things we know in a given question. Okay, so I'm going to start by listing that information on the left side, kind of as I'm reading the question out loud. So it says Rosie invested $7,000. Rosie invested, that's the principal. She invested $7,000 into a 2-year, so it sounds like time, a 2-year simple interest Canada Savings Bond that earns 8.25% annually. That means every year. So the interest rate was 8%, really 8.25, and that looks like 0.0825. So I've divided it by 100 to put it in decimal form. The question here is how much interest did Rosie earn? So I don't know the I answer to that equation, but we're going to multiply the principal times the rate times the time. The rate was 0.0825 and the time is 2 years. So with a calculator, I have found that that is $1,155. Okay, so in 2 years, that's a pretty decent interest rate. That's actually higher than what's normal these days. But she's earned an extra $1,155. Part B of this question says how much is the investment going to be worth at the end of the whole term? So after 2 years, how much money will she have? And this is going to introduce one new equation. Her final amount, A, of money is going to be made up of the principal that she started with and the interest that she's earned. So we can add those 2 numbers together. So here we had 7,000 to start with and 1,155. Adding those together, she's going to end up with $8,155 after 2 years. All right, so there's example 1, simple interest. You'll notice that this equation has no exponents in it. This is the linear one, graph number 1, where we're growing our amount of money kind of with steady linear growth, the same amount every year. So we don't need an exponent in this equation. All right, example number 2. Matt invests $500 in a GIC. It stands for guaranteed investment, is the GI. So he invests $500, that's the principal, and a GIC that earns simple interest. So it is important to pay attention. All of these questions so far are simple interest questions. But when you get to your quiz at the end of tomorrow, there's going to be a mixture of simple and compound interest. So you'll have to be paying attention to that word so you choose the right formula. It says after 4 years, so a time of 4 years, he will have earned $80 in interest. So this time I know the interest amount. And the question here is, what was the simple interest rate? All right, so it's the same type of question, but just a different unknown. So I'm going to start with the equation again. I equals PRT. I like to say I party as my way of remembering that equation. I party. There's lots of tricks for remembering stuff. That one, for some reason, works for me. At this point, you could take any of the values and substitute them if you like to do your number stuff first, or you can rearrange the equation for R, since that's the variable we're going to be solving for. So I'm going to do that. I want R by itself, and right now it's being multiplied by P and T. I want to get rid of those. So there goes P, there goes T. I just totally changed the equation though. Now it says I equals R, which is not true because I needed to divide the left side by the same thing. Okay, so I have just done some rearranging. That means the interest rate, so I'm going to switch the sides, the interest rate R is equal to the interest amount divided by the principal times the time. Okay, so now I'm going to take these numbers that were given in the question. The interest amount was $80, the principal amount was $500, and the time is 4 years. Doing some simplifying, that denominator, 500 times 4 becomes 2,000. 80 divided by 2,000 is 0.04. And that's the decimal version. R is always the decimal version of the interest rate. So in my final statement, I'm going to change it back to a percent. Therefore, the interest rate was 4%. So to do that, we're multiplying by 100% to change it back into percent form. All right, so there's example 2. You can pause, rewatch, or just pause and copy, whatever you need to do to get that example down. So there's one last example. So far we've done a question where we solve for the amount of interest. We've done a question where we solve for the interest rate. And let's see what this last question is about. What twist it's going to throw. So Sasha had a Visa balance of $4,500 that was 60 days overdue. The annual simple interest rate on the credit card is 24%. Ouch. That's a big interest rate. First off, we're going to change or express 60 days into a number of years. So for simple interest, remember the equation is I equals PRT, and T is always in years. So let's make that change first. So 60 days is a fraction of a year, and it's a fraction out of 365 days. 60 out of 365 is approximately 0.16438, or 16% of the year, but the decimal version is just fine. Okay, part B of this question, how much interest did Sasha pay? Oh, I'm just gonna move this up a little bit so I have more room for the work. How much interest did she pay? So the question here is, what is I? That means we must know the principal, 4,500, the rate, which is 24%, 0.24, and now we know the time is 0.16438 years. Okay, so this is an important first step, must be in years. Because we're given an annual interest rate that assumes you're talking about years. We already rearranged this formula on the last slide, so I'm just going to start with the rearranged version. P over RT. Oh my goodness, I'm crazy. We don't need this rearranged. Rewind. I equals PRT. We're solving for interest, just like the formula is meant for. That was silly. Then we can just substitute the given information. 4,500 for the principal times 0.24 for the rate times 0.16438 as the time in years. Multiplying those together, my answer is $184.93. So 60 days overdue. That's only 2 months that she was holding onto this Visa balance, and that cost her an extra $184 on top of what she already borrowed on the Visa. So credit cards, they can be trouble because the interest rates are quite high if you're not able to pay off your Visa balance. Okay, so that's it for the note. I have, I'm just going to change this one. Simple interest. So that's what our questions were all about here. I've included this little picture. I'm not sure if you've used one of these triangles before to do rearranging, but it's a tool that I've seen some people use in science classes, sometimes in math too. So our formula was I equals PRT. So that kind of fits into this triangle that some people like to use, where interest is equal to, and then we can split the PRT across the bottom. And what you see with the hand there is, if you have a question where you're not solving for interest, but you're solving for principal instead, so how much principal must be deposited, I algebraically rearranged that equation in my example. But another way of doing this is using the triangle and saying if you're solving for principal, hide that part of the equation, and that lets you see the other side of the fraction. So I on top of RT. So it's a visual tool. If you like it, you can use it. If you're happy with just rearranging algebraically, like dividing by the parts that you don't want, you can rearrange that any way that works for you. So there is a little bit of practice for this, page 352 in your textbook. If you didn't happen to bring your textbook home, I don't know where you would have left it, but let me know and I can send you a photo of the corresponding pages so you can do that homework.